What's going on, everyone? So there's a flat earther on TikTok named Tron who keeps insisting that no gyroscope manuals mention 15 degree per hour drift or Earth's rotation. He's not a pilot. I've heard claims he was a helicopter maintenance person or something for a while, but like a lot of flat earther resumes, it seems to have a lot of vague and kind of wishy-washy background. Even sounds like he's unsure if that's what he did. So let's do the work he doesn't want to. So the first one we're going to look at is this Handbook, Operation Services, and Overhaul Instructions Directional Gyroscope Indicators by the Air Force. So right here, the latitude corrector is a calibrated nut which may be adjusted in or out on a threaded stud on the gyro's housing to minimize gyro drift due to Earth's rotation. The drift is 0 at the equator and maximum at the poles. Then we have the Intelligent Fiber-Optic Gyro Operating Manual from Tritech. And here we're talking about drift. Unfortunately, this is not the case, for the gyro tends to drift away from the original alignment due to friction in its support bearings or other disturbing forces, including precession due to the rotation of Earth. In that same manual, there's another spot that says, two main sources of drift for the IFG are Earth drift and sensor drift. Earth drift occurs because the IFG measures Earth's rotation as the world spins beneath it. And here's a little diagram. Then we have the Royal Canadian Air Force description and maintenance instructions for the Sperry Gyroscope-Compass. In the leveling system, bearing friction, unbalance, and drift because of the Earth's rotation may cause the rotor to tilt from its vertical plane of rotation. From PilotMall.com, watch your altitude, a complete guide to aircraft attitude indicators. Gyroscopic precession. Since the Earth rotates at 15 degrees per hour, the attitude indicators' gyro alignments drift away from the actual horizon over time. Then we have this from CFI Notebook, heading indicator, precession. Because the Earth rotates 15 degrees per hour and because of small accumulated errors, cause of friction, the HI will drift over time and must be reset. This is from the FAA.gov, Chapter 8, Flight Instruments. Talks about precession and whatnot, and it says another error in the heading indicator is caused by the fact that the gyro is oriented in space, and the Earth rotates in space at a rate of 15 degrees in 1 hour. Thus, discounting the precession caused by friction, the heading indicator may indicate as much as a 15-degree error every hour of operation. Then from goldmethod.com, Instrument Flying Handbook. The Earth constantly rotates at 15 degrees per hour while the gyro is maintaining a position relative to space, thus causing the apparent drift in the displayed heading of 15 degrees per hour. Then on pilot18.com, a company that helps you get your pilot license, gyroscopes. It has diagrams talking about gyroscopic precession. At the poles, the rate of apparent drift is equal to the rate of Earth's rotation, 15 degrees per hour. And you can do math to calculate this. Interesting. Sperry, a company that makes them, gyro compasses and gyro pilot manual. Let's see what Sperry has to say. Because it is affected by both the horizontal component and the vertical component of Earth's rotation, and it seems to have all of these diagrams and graphs that show a globe Earth. Another spot in that same manual, as the compass is moved away from the equator, the vertical component of the Earth's rotation begins to take effect. Now Tron will cry, that's not a ring laser gyroscope. Correct, ring laser gyroscopes are a different sensor class, and that's the point. Modern inertial systems explicitly model and compensate for Earth rate. RLGs and FOGs are sensitive enough to measure Earth's rotation directly, and the INS and AHRS then applies Earth rate. So we'll learn about that. The INS and RIRS, Inertial Navigation System and Inertial Reference System. Gyroscopes must compensate for the effects of the rate which they are transported over the Earth's surface, and for those of Earth's rotation, which is what Earth rate is. Now, this is a Honeywell ring laser gyroscope. This is the engineering document for that said Honeywell ring laser gyroscope. And when we look in the engineering document, it says a test run of the ring laser gyroscope with an angular random walk of 0.0135 degrees per hour fixed to a stationary mount and measuring Earth rate produces an Allan variance plot. So let's clear some things up. Hey Google, what's Earth rate? Earth rate refers to the movement through space, which includes two primary rates, the rotation speed on its axis and the orbital speed around the sun. Now you might not like Google, so hey Grok, what's Earth rate? The term Earth rate blah blah blah. Since you didn't specify, I'll assume you're asking about the Earth's rotation rate. Since we might not trust Grok, we'll try ChatGPT. What's Earth rate? Earth rate could refer to a number of things. Earth's rotation, 360 degrees in 24 hours. Earth rate in INS, term used in aerospace and navigation, refers to the angular velocity of Earth's rotation. Maybe we don't like those. Hey, DuckDuckGo, what's Earth rate? And wouldn't you know, it talks about Earth's rotation. So they don't ignore Earth's spin, and that's why you're not seeing it in the little one-sheeter that you like to look at, Tron. They know how well Earth spins, so they just know how to program this thing to compensate for it. So I'd like to thank you for coming to my TED Talk on reading the entire manual. If you actually do the research, the physics, procedures, and documentation all line up. And if you're feeling really froggy, you can go learn to be a private pilot yourself. It runs somewhere between 12 and 15,000 on the low end. I'm sure you could make that back within a year. Have a good one, and if you see Tron on TikTok, let him know he's been wrong.